Okay, this is me documenting a probably useless project that I wanted to do and I've just completed. Basically I wrote a computer game for the Mattel Aquarius, and I then decided I wanted to do like a presentation screen to go with it. But because I found it difficult to compress the graphic data into BASIC, because you basically got data statements, the program became quite large and therefore took a long time to load. So you ended up with the scenario where you were waiting a long time for the game to load, and then all of a sudden you present with all the data. What I wanted to do was to produce a system or a methodology where you could have the screen display as it was loading, and that's what I've tried to do here. So if I press return, okay, that gets us to there, and then of course I press Control Z, which gives us C load, return. So now it's essentially starting my tape player, which should hopefully give me the loading on the screen. There we are. The program's called Quaid, or the game's called Quaid. So this is now loading off my tape machine. So mini disc going through my Aquarius mod device, which I've documented elsewhere, and going in, so it's just an audio file. So that's loaded now. So I can now go run and return. So the tape player is still playing, and there's a 10-second gap, and then after that, here we go. So this data is loading directly off the tape drive. The tape drive is running, the data is coming in, and it's getting shoved onto the loading screen. Okay, and then what will happen at the end? It's still putting the graphic in. Basically, the data is just getting dumped straight into the graphics part of the memory at the moment. So it does the graphics first, then the colour next. So now you've got something interesting to look at. And then what it'll do is it'll then go into the next part where it'll actually load the real program off the machine. And this is the bit where I'm going to have to wait a minute and a half actually waiting for the program to load, but at least I've got something semi-interesting to look at. Okay, so that's doing this. So basically I've made the whole program quite quick to load now, because this graphical data was taking about 5K of basic information to save onto the tape. Now, because I'm saving it as raw data, it's only 2K. So basically there's about half a K of loader program, 2K of this, and then the actual real program, which is about 5K. And the whole thing loads, I think, in about 2.5 minutes. The mini display is running down. I found the mini display works very well because it's got a line input, so I can create the program on a PC, save the programs as an audio file straight onto the mini disc, and then, like I say, with the tape mod I've done, it'll load straight in. So very soon the tape loading should complete. Far off this point, I don't think. There we go. So this is now the second program loading, and I can start the game and I can play the game. Okay. So a demonstration, or I'm now going to do a sort of brief description of how I've achieved this, which somebody somewhere may possibly find interesting, and I'll also put a link in the description of this video to some of the code and some of the audio files that I produced, that so you can see this working on your own Aquarius. Okay, so this bit. Okay, so this is a brief description of what I've done to achieve that loading and dual basic loading seamlessly thing. I'm not in any way an 8-bit programmer. I played with BASIC when I was a kid on this machine, and then went on to do databases and SQL and all that. But 8-bit programming machine language is something I'm trying to learn now. Right, I'm just going to go through the memory of the Aquarius. It starts off obviously at 0, and the first 8K is the ROM. There's then a gap, which is where the extended BASIC goes if you insert that cartridge. And then the magic numbers are 12288. That's the start of the screen RAM. This is where the characters that appear on the screen are stored, from 12288. And the first 1000 characters is the actual physical character. And then starting at 13312 is the colour. In other words, what colour appears in each character. And I think it's explained quite well in the manual. And these overlap, so the colour overlaps onto the characters. There's then 256 bytes of system information, and then the basic program starts. So you start writing the basic program at 1592. What I want to try and achieve is I've got a program which is a loader. And it's going to load off tape and place into this area here the screen data, which is fair enough. And then this loader program is then going to install a larger basic program, which is the actual game. Okay, and the first problem I came across, which I wasn't expecting, is that when you run a program like this, what it does is it creates a reserved area for the variables that you use in the program. Say A equals 1, well, that gets stored there just after the code of the program. And this area appears to be reserved when you press run, when you type in run. So when you press run, it reserves the area, runs the program, storing the information in this little variable space here. Now when I was loading the data for the screen, that wasn't an issue, but when I was loading the second program, I was in fact injecting the second program at the beginning in the same place. And what was happening was, and this was done in a machine code, and what it was doing is it was loading all the program up great, but then when it was returning to basic, in order to run the program amongst other things, these variables were still sat there in the middle of the program, and that was corrupting. Okay, so now if you look at the loader program, you'll see that what it does is it alters the position for the variable data, and what it does is it removes it from there and it pushes it right down here near the limit for the 16K, well 18K, isn't it? So it pushes the variables right out of the way, and then it issues a second run command. So although it looks a bit superfluous, okay, so the program starts, it does a jump and bypasses this bit of the code for a reason I'll come back to. This here is the bit that moves the variables to its new location right down in the memory, and then I issue a run 30, and what that does is initializes this information. Otherwise it doesn't move. So the second run command, although it wouldn't normally serve any purpose, it does reset this information here. So then it loads in the machine code for the graphic load. It then runs that machine code. It then runs the machine code to load the program. Okay, and then but what you'll see is that although I load the data in for the machine code, I don't actually call it until we go right back to the beginning again. So I'm calling the second piece of machine code, the one that loads the program, here. And the reason I'm doing that is because when it loads the second program, what you will see is, in actual fact, the first few lines of both programs are identical. And that's because when this call to the machine code happens, the computer is then sat in machine code, but eventually it'll come back to this point here. Okay, but what's happening during the machine code bit is the actual fact the code is getting changed, and I need it to hit this point here on the second program, and it does, and then it just runs the second program. And I put that extra run in there just to make sure that it does initialize everything and runs the second program. Great. So that's how I've managed to get it to go to machine code and then come back into the second program and just continue running. It's a bit of a cheat in that the first 4 or 5 lines of the program are identical, and therefore the computer has no idea that in actual fact the basic has changed underneath. So that's trick 1. Just to explain how the machine code works, I've actually re-decompiled it. I originally wrote it in like this with pen and paper, and then converted it to the machine code data. But it was scattered over lots of different papers. So what I've actually done this morning is I've actually rewritten it back out again. So the machine code that loads the graphic part that you've seen, I found out that what you have to do is first of all disable the interrupts. I think that's because it tries to scan the keyboard and you don't need to do that. It then calls a ROM routine. Now there's a ROM routine that reads the sync information from the tape. So that's great, just use that. So that gets rid of the header off the tape, and now you're ready. I've then got a loop here that loops 6 times, and every time it loops, it again calls a ROM routine which reads 1 byte from the tape. Now this is the actual as far as I remember, the title of the data stream, which, because it's a array variable stream, will always be hash 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 6 hashes. Alright, so basically all that does is it dumps these 6 hashes. So now I'm at the point where I'm ready to reload the screen data in. So I set HL to 12288, which is the position for the character RAM. I then load into BC07FF. Now I've done this because I want to read 2048 characters off the tape. I probably could have done it a different way, and I think I probably have done it a different way when I'm reading the program later on, in that you just look for the end of file marker. But okay, so I've just got it counting in this particular version. It then calls a routine to read 1 byte. In fact, it's the same routine as what's up here to read 1 byte. Except instead of just discounting it, what I'm actually doing now is I'm loading that byte into HL, which is the pointer to the first memory location in the graphics. And then incrementing HL, so now going to the second position on the graphic screen. Decrementing BC, which is my counter. So now my counter is not 2047, it's now 2046. I'm ORing A and C to try and get 0. I'm loading B into A, and then I'm ORing A into C, and the effect will be that when BC equals 0, that's when it'll do the jump. Okay. Again, I don't know why I've done this, but I should have really done a jump, not 0, but here we go. I've got a jump 0, so basically when the counter runs out, when it's gone through all 247 positions, or 248 positions including 0, it jumps to here. Otherwise it goes back and it reads the next piece of data and the next piece of data and the next piece of data, and it just keeps going round and round and round until it gets to 0, and then when it gets to 0 it falls to here. This re-enables the interrupts and then returns the program back to basic, which is which at this point will be here. So that's where we are in the program. Right, so loaded the machine code. I've run the machine code there. It's loaded the data into the graphics area, and then it reloads the second piece of machine code. Now, I haven't decompiled this, but it's basically the same as the first. The only big difference is that the pointer is now this pointer here, 14592, which is the beginning of the basic, and it doesn't use the counter to detect when it's reached the end of the program. It uses the end of file marker. But like I say, what happens is it doesn't actually execute. That's where it actually compiles the machine code into the memory cells, but it doesn't actually run it until it gets to the end of file marker there, or the end of data marker there. Jumps to 10. 10 executes the loader for the program, for the game program, the program we actually want to load. And like I say, by the time it returns from this user R, this information has been overwritten with this information, so in actual fact it returns here, and by this point it can run the game. Right, was that too complicated? I don't know, made sense to me at the time. And now looking through this, I've realised now that I've made a few bad choices in some of the machine code. Part of the reason was because I kept on running into it didn't work the way I wanted it to work. It kept crashing, and I couldn't understand why. And I was going round and round in circles, and I was trying different things. And unfortunately, it came down to an error in my documentation. This here is the computer's pointer to the where the variables are stored, and on the documentation I had, it actually said 14451 was that location, and it wasn't that location. It was actually 14551. So it was an error in the documentation, and I spent quite a long time being frustrated and trying different things, trying to figure out why this program wasn't working, before I realised that was the error. I changed that 4 to a 5, and hey presto, it all just lit up and worked. So that's it. So like I say, I don't know, it's very possible that someone's done all this before and this is a known procedure, but I've certainly enjoyed myself at the end of the day, sense of achievement in learning enough about machine code, enough about the ROM routines that are in the Aquarius to make it do what I want to do, and indeed the actual game itself, which was a challenge because I originally wanted it to work in 1.7K, which I've achieved, and then later on wanted to do the graphic, got that to work, and then wanted to use it. I wanted to load the graphic as like a loader screen, like it used to do with my Commodore 16 and indeed Commodore 64 later on. So I'm quite happy I've done it. But anyway, that's it. Bye now.